Okay, so this is my video project for the end of chemistry. And I decided to do it on chapter 14 of Who Killed Dr. Thompson, a forensic mystery. So basically, the story is Dr. Thompson, for about 20 years, he came up with this new cancer treatment drug that they called Zeta 12. And he had like undergraduates and students and things like that throughout the years helping him with this drug. And he finally got to the end. But when he had people um, helping him with it, they had to sign an NDA, and they also had to sign a contract saying that they weren't going to get paid or get any credit for their contribution to the work. So he was going to take all the credit. But on the evening of August 1st, he got a call when he was at home. He had I think 2 weeks until he was gonna bring this drug into like R&D for it actually being produced as a cancer treatment drug. And he got a call, and the other person was somebody that was at his lab, and they were looking into a fire that was happening. So his lab burned down. And it's a very interesting topic because they go into burn patterns from chemicals. And they started talking about some chemicals like gasoline release 47 kilojoules of heat per gram of fuel. And in order for the damage to be done, sufficient heat must be transferred from the burning fuel to the material. An example of this is vinyl. Toluene has a high boiling point, a low validity, but relatively low flash point, high flammability. So these points are important for what happened in this story. So in addition to that last point, I learned that the flammability of a liquid is related to the concentration of its vapor in the air. And the vapor pressure of a liquid is directly dependent on its temperature, which I had no idea about before I read this. Lower flammability limit, or the LFL, is the lowest concentration of a solvent vapor that can ignite in the air. And the flash point of a solvent occurs when the vapor pressure of a solvent equals its LFL and combustion is possible in the presence of the ignition source. The auto-ignition temperature, on the other hand, corresponds to the minimum temperature at which the vapor spontaneously ignites, even in the absence of the ignition source, which is very interesting because they're trying to figure out, how did his lab burn down? Did somebody burn it down? Was it some of these chemicals that he had there that, was it a freak accident? So what really happened? Gas chromatography is a simple and rapid analytical technique commonly used to identify separate components in the mixtures of liquids or gases. So I'm going through the points that I learned in the chemistry of this. And this is a small thing, seemingly small thing, but ends up being very crucial to the story. A safety match, which you would strike against the side of the box to light it, is made up of wood, but the combustible tip is made up of potassium chlorate and glass. And the striking surface on the side of the box also contains glass and an entropy of phosphorus called red phosphorus, which is reasonably stable at room temperature, but when struck against the side of the box, the glass creates friction and heat that converts the red phosphorus into the much more reactive white phosphorus. This is important for the story because safety matches are different than strike anywhere matches. And strike anywhere matches were found at the scene of the fire or strike where in the laboratory. And strike anywhere matches have a higher risk of accidentally igniting. So again, it's just a mystery of, how did this fire start? Then they go into the different fire extinguishers used, which I used to do fire suppression, and I was really interested to know that there were more classifications of extinguishers that I had no idea about. So the different fire extinguishers used for different fire types, we have Class A, which is a fire of wood, paper, and plastics. It says to use only water. Class B, which is flammable liquids such as solvents, gases, petroleum, oils, paint, flammable gases like methane, propane, and butane. Use carbon dioxide or dry chemical extinguishers, ammonium phosphate, sodium bicarbonate, or potassium chloride. Class C, electrical fires. Some use the same extinguishers as Class B. Class D is combustible metals. Use dry powdered extinguishers such as graphite or sodium chloride powders pressurized with nitrogen gas. Class K, cooking oils and greases. Use wet chemical extinguishers, aqueous potassium carbonate containing detergents to improve the wettability of the nonpolar grease. So at a point in the story, once Dr. Thompson was finally able to go back to his laboratory, he went and he was hit by a car and his research was stolen. And they were trying to figure out who murdered him because it looked like a murder. And the conclusion was through the polymerase, sorry, that word is still difficult, polymerase chain reaction, extracted DNA can be amplified. The double helix is denatured into individual strands by heating to high temperatures of 94 degrees Celsius and then cooled to 72 degrees Celsius. Nucleotides to the single strands then cooled to 72 degrees Celsius, and the enzyme Taq polymerase is added, which adds complementary nucleotides to the single strands of DNA, giving rise to two identical molecules. The process is then repeated many times, which yields billions of copies of the original DNA sample. Once the sample is amplified, they are separated and detected using electrophoresis, which involves the DNA molecules being transported through a gel under the influence of an amplified electric field. Because the phosphate backbone of the DNA is negatively charged, the DNA is pulled through the gel towards the positive electrode. The larger the DNA molecule, the slower it should migrate through the gel. The repeat patterns in everybody's DNA is different, which gives rise to differences in the resultant electropherogram and the output from the electrophoresis. For DNA profiling, however, and this is how they figured out who did it, instead of reading the output from gel electrophoresis, faster and more automated capillary electrophoresis is used, where DNA passes through a small tube called the capillary rather than the gel. The pattern of peaks created is a person's DNA fingerprint. This may be matched to evidence found at the crime scene. And in this case, the evidence that they found was cigarette butts, and it led to one of the people that helped him create that didn't get any of the credit. Dr. Littleton was the killer.